Today we're not really learning anything new. It's just ramping up the difficulty one notch or so. Solving multi-step inequalities. We're not adding any new rules today. We're just making the inequalities we have to solve a little bit bigger. If anyone is still struggling with the order for two-step equations or inequalities like this, you got to practice. You got to take the feedback I give. Okay, we have the specific strategy I had written on the whiteboard for so long, and then we had the backup strategy, which is following an opposite order of operations. So if I'm y, if I followed order of operations and plugged a number in, I would divide first, and then I would add. Opposite order of operations is usually a good strategy for solving. We should get rid of the addition first. And then this next step, y is divided by -6. So we multiply by -6. And this is where I'd expect everyone to yell shout, or yell flip, shout flip at me, because I multiplied or divided by a negative. So my symbol should be flipped. The -6's cancel out. Y is now greater than -12. And a lot of these problems are going to ask us to graph our solutions. It's just something nice to practice, I guess. We'll have to do it, and it doesn't take much time, so put the number we're comparing to in the middle, one number bigger and one number smaller. Open circle, because I don't have the or equal to line, and I'm y is bigger, so I want to shade to the bigger side, going towards the positives. All right, there's the first example. I'll do one more, and we'll have a handful that we do together in class. So hop up here. Now we've got 2v minus 4 greater than or equal to 8. So some of you might be wondering why this is even a separate lesson. It's just ramping up the difficulty a tiny, tiny bit, just to get us more and more used to solving these. All the rules are really the same besides that flip step right there. So I'm going to add 4 to get rid of the -4. Then I'm going to divide by 2. Do you think I should flip here? The answer is no. It's only when it's multiplying or dividing by a negative number. So the algebra step I write out, if that's a negative number I'm multiplying or dividing by, that's when I would flip. So this one stays. V greater than or equal to 6. Again, I'll throw the graph up one more time. 6 in the middle, one number smaller, one number bigger. Now I do get a closed circle because I've got my or equal to sign. And V is greater than 6. The alligator's eating the V. So I'd shade to the right because that's the bigger numbers. So this next bit, again, all the same algebra steps, but if you remember last chapter, and we were pretty good at this last chapter, but deciding whether things had one solution, infinitely many, or no solutions. So let's solve this. My first step should be the distributive property. And after this first step, some of you were able to tell me what you thought the answer was. Okay, but now we have to take it one step further. So in these problems, the special solutions still happen when both variables cancel out. But now, we can't just immediately say this is no solution. We have to check if the inequality is true. The alligator is eating the -3. Is -3 bigger than 12? That is a false statement. So think back to when we were doing the true-false problems in class. This is a false statement, so it's no solution. That means no matter what we plug in for B, the inequality will never come out true. So that's a no solution. Let's throw one more up here that's also on the notes. So I've got 2 and then in parentheses 5w minus 1 less than or equal to 7 plus 10w. Again, I'll start my algebra steps by distributing, just following our strategy that was on the whiteboard. Then I'll try to get the w's together, but they're both 10w, so they're going to cancel, just like we'd expect from a special solution problem. And now I have to check if the inequality is true or false. Alligator's eating the 7. 7 is bigger than -2, so that's true. This is in all real numbers. Or infinitely many solutions. All right, so that's the other special solution example. We can get all real numbers and no solution again. And it happens in the same way. The variables cancel out. It's just instead of saying, oh, they match or they don't match, we actually have to check for true or false like we did on the 2.1 notes. Last problem for these notes is basically something making us calculate an average, making sure we scored enough to move on to the next round of a game. So it says we need a mean score. When you see that word mean in math, we're talking about average. Add them up and divide by how many numbers there were. We need at least 90 points to advance in whatever game we're playing. So we want to know what fifth game scores allow us to advance. So, as we've talked about before, we always want to look for the number that sounds like a minimum or a maximum. At least 90, that sounds like a minimum to me. So a minimum of 90. And then these are our game scores. So we're going to play a fifth game, and we want the average to be at least 90. All right, so average of at least 90, 5 games. We don't know the fifth game, but that's okay. When we don't know a number, we just fill it in with a variable. So 95 plus 91 plus 77 plus 89 plus a fifth game, x, divided by 5, divided by how many numbers we're adding together, and we want to be at least 90. 90 is okay, bigger than 90 is okay, less than 90 is not. So, something I've showed a couple of you when you've asked, we actually pretend like this is all in parentheses up here. So don't go subtracting these numbers to the other side. We actually want to get rid of the 5 on bottom first in this situation. Okay, we can't really do anything with what's in parentheses until that 5 is gone. So we could add all of these numbers together, but let's multiply by 5 first. So multiply both sides by 5. They'll cancel out over here. Then times 5 over here. So we need our 5 games to add up to at least 450, which I hope makes sense. If we need an average of 90, this would be the number if we got exactly 90 per game. All right, so now let's start adding these together. 95 plus 91 is 186, plus 77 is 263, plus 89 is 362. So right now we're sitting at, 352. Right now we're sitting at 352 plus x. Now we would subtract that to the other side as our last step in our equation. And we need at least a 98 on this last trivia game. Okay? So there's an example of a word problem. The part that I really think would have messed with us is the mean. Would you have been able to tell that you added x in with the rest of these numbers and then divided by 5 instead of averaging these and dividing by 4? That's the decision I think we might have struggled with a little bit. But then over here, logically speaking, if we need an average of 90, then if we add 5 games of 90 together, that's the minimum we can expect to need. So there's a couple trains of thought here. This is the one I prefer you go down, of course. Getting better at actually writing out full equations. A lot of times you can just reason through these problems, but at the same time we want to get a little better at the technical skills. All right, well, that's it for the notes. Nice short one again.